This slide tells it all. Today we're going to talk about the simple linear regression line, where it's also called the line of best fit, the concept of residuals, and finally, how to interpret the slope. A quick refresher on how you write the equation of a line. Throw back to algebra. Y equals mx plus b. The b is very easy to interpret. It's where the line crosses the y-axis, right there, where it's the y coordinate of where it crosses the x-axis, and at that time, x is 0. The slope. How are we going to interpret the slope? Well, you can say it's the change in y or the change in x, and that certainly is the case. I kind of like to think of it this way. This is the miles, this is the destination, where you started driving. This is where you ended driving. So you drive along a horizontal road so many miles, and then you drive along a vertical while so many miles, and so you're measuring how much mileage did you go horizontally compared to how much miles you drove vertically. So I'm going to introduce two examples, and I'm going to cheat a bit. I'm going to actually give you the equation of the line of best fit, knowing full well that StatCrunch is going to do that for us. The scenario: a manager of a bookstore wants to predict what the sales will be in thousands of dollars on a day when he has a certain number of salespersons working. Well, it's only fair to show you the data. Here's the data. The data ranges from a day when there's only 2 salespersons working to when there were 22 working. And here are the corresponding or associated sales on those days. Look at this data value. When 9 salespersons were working, the predicted Y value is 19, or $19,000 in sales. So I'm definitely leading up to something. I'm leading up to the concept of a residual. A residual is the actual observed Y value. When you take a particular point, and we pick the point 9, 19, the observed Y value compared to what the regression line predicted. Observed minus predicted. It measures the distance of the data point from the regression line. Another picture. Here's a scatter plot. Here's some data points, some x, y values. In this case, the y value is above the prediction line. So if you did the observed y value minus the predicted y value, it would be positive. Contrary to that, if you pick this point below the line and you took the observed y value minus the one that's predicted, it would be negative. Long story short, if data values are below the regression line, the residuals be negative. If they are above the regression line, the residuals be positive. Now, I know you think these points are on the line, but they're not. They're a teeny tiny bit off the line, so they still have a residual. Let's compute a residual. And the thought is it's observed y minus predicted y. Here's the observed y value for the data point we decided we're going to focus on. On that certain day, there was 9 salespersons working, and there were $19,000 worth of sales. How do we find the predicted value? Makes sense. Here is the simple linear regression equation, and we want to find out what's happening when there are 9 salespersons working. What will be the predicted sales on that day? So we substitute 9 in for the salespersons working, substitute it into the equation. Remember, you multiply before you add. So we multiply 9 times this decimal, and we come up with 6.588. So this is 6.588. We take the 6.588 and add this y-intercept of 9.743. And we come up with a predicted y value. This is a point that's actually on the prediction line, because we use the prediction line to predict it. So we have 2 y values now. We have the observed, the one that was part of that xy combo, the observed y value, and we have the predicted y value. We want to see what the residual is. So we take the observed y, 19, minus the predicted y, 16.331, and the answer is 2.699. So sure enough, it's positive. It's above the prediction line. Now let's put that 2.669 into clear English. On a day when there were 9 salespeople working, the sales were, and I'm converting this into thousands by multiplying this number by 1,000. On the day when that particular day, when there were 9 salespersons working, sales were $2,669 more than the typical day when you would have 9 salespersons working. It was a little bit unusual, all right? It was higher than expected. That's the power of the residual. Here's our data value, 9 salespersons working, $19,000 in sales. There's that guy right there. Project that point onto the regression line. Okay, X is still 9, but what did we expect? X is still 9, but we predict only $16,033 in sales. Okay, what we observed was higher than what was predicted. So we're going to end this discussion today with an interpretation of the slope. The slope was 0.332, and the blase definition is it's a change in y over change in x. But we have to be explicit. What was y? It was sales. So it was a change in sales with units, thousands of dollars, compared to the change in salespersons working that day. So you can work it a couple of ways. You can start with the denominator and let the denominator be 1. For each additional salespersons working, so when the salespersons change by 1, each additional salespersons working, the sales will increase by $732,000. Or you can go the other way. You can say, let's start with the Y. When the sales go up $732, for each additional increase of $732, that would correspond to an additional salesperson working. Or I looked at your homework and they do it this way. The sales will increase $732 for each unit increase in salespersons working. Well, a unit is 1. So that's just another way of saying it. So I'm going to leave you with that. And again, it's a lot. We have a simple linear regression equation. We have the actual equation. There it is. And we used it to find a predicted value. We explored the concept of residual, observed minus predicted. We did all of that stuff by hand. We computed the residual by hand, and then we interpreted it. The only thing we didn't do the math for was the formula for the slope and the formula for the y-intercept. Again, it's really not worth the tediousness of going through the mechanics of evaluating these coefficients by hand. So the regression line will be part of the output of StatCrunch. The other thing that's part of the not the residuals, although there's an option to request the residuals, and I can show you that when I do my video on StatCrunch for simple linear regression. And let's see, it will not, it's certainly not interpret a residual. That's your job. It handed you the slope, and it is your job to interpret the slope. So I guess what I'm saying when it comes to things that you're responsible for, and that won't be given to you in a printout of StatCrunch, is all the interpretations. The interpretation of the slope, the interpretation of the residual. In the previous slide on scatter plots, they will ask you, is this scatter plot strong positive, moderate positive, blah, blah, blah. Is it 0? They will ask you to interpret the coefficient of determination. They will give you R. They will give you the coefficient of determination, and it will be your job to interpret it. As always, I hope you find this interesting, this presentation interesting, and most importantly, I hope you found it informative.